Okay, I guess we're live, so yeah, I'm just doing some programming, homies. So, the goal of what we're trying to implement, which I'm totally gonna just use Copilot for, although it's probably not gonna work, but this is like a whole neural net thing, and so like every this represents a single neuron. I mean, all of these represent a single neuron, and we have 32 inputs because we're in n equals 5, like we're doing all the binary inputs. And, so it's like this is the, every neuron has a parameter vector, and then it's ranking all of the inputs by similarity to the parameter vector. And then you have a bias that determines the output based on how similar you are to the parameter vector. And that is how neural nets work, except we are, multilayer perceptrons. It's unclear, like attention mechanisms, they seem to be different. Yeah, maybe I'll do a visualization of attention mechanisms in the future. Because also the main thing about attention mechanisms is they have like multi-head. Anyway, I got parlayed there. Now I have to backtrack. Oh man. Yeah, so like the whole bias thing, right? So, So basically we have this thing where it's like, like you can click on this input, and then it propagates through the network, right? So it's like whatever this input is, it's plus, it's assigned a red here. So it's like above the bias is red always, below the bias is blue in the color scheme here. So we have like red, blue. So then if we look at this guy, he's being mapped to this activation. He's like red, blue. But then this particular activation is, like red, blue. So up here we have red, blue. Like that's like how neural net works. And also we can go backwards, so like I can see what other points are being selected, and what we're trying to figure out is like what kinds of point sets are like hard, or yeah, like what kind of point sets are hard for this computational setup. And but what we're doing right now is we're going to like be able to select point sets in the code, and then they will be like highlighted. I think probably what we'll do is just have a circle, an outer circle around them if you're a selected point. And yeah, right, so that's basically what we're going to try to implement. The problem is that like our code base is, it's like half AI, half human. It's 800 lines of code. It's like, it's freaking terrible. And I guess like you're supposed to like break it up into different files. Anyway, yeah. Okay, so I'm gonna see what Copilot does for me here, because I'm going to say, yeah, okay, so like, I would like to add a feature and code. I would like to, right, I mean, basically, the selected points are going to be fixed. So it shouldn't be that hard, actually. That should not be that hard. I'm gonna do it manually, isn't it? Hey guys, I'm just gonna have like const selected points. Wait, do I want to call them that? Because no. Yeah, just call them selected points. Okay. So for instance, right, and we have to manually put them in. And I don't actually know what they look like. Where do I produce all the points? Oh man. So I don't know where the points are being produced. Yeah, we'll just call them that. That's fine. Okay, so we'll just do, like, for now, we'll just do whoops. We'll just do dang, man. We'll just do 2. I think that's... Are they like that? I don't know if they have commas or not. That's kind of my problem. So we'll just do those 2. And then we just want to display a circle around, which I guess is happening right here. No, this is a different thing. Yeah. I should get rid of those. Display parameters. Here we go, display unit. Yes. Yes. Okay. Okay. So, what we need, are we activations, iterate over keys. Right, that's where it's going to get hairy, because we have to propagate. Right. Right. Yeah. So grouped activations. Yeah, I feel like the rest of this is going to be entirely unwatchable. I mean, they're basically unwatchable to begin with, so. Right. So, really, yeah, like we just want the rows. I mean, the thing is I don't know the logical place to do this. I'm gonna call this selected rows, which is going to be annoying, but so we'll say 0, 31, or the equivalent rows, and then when I go to display unit, yeah, I think that's okay, but right, so it's just like for this layer, we need to figure out the selected activations for this layer. That's where it gets a little hairy. Iterate over keys and grouped activations. Right. Okay. Okay, so I need a thing where it's like... Determine the activations of the selected... Is it rows? I forgot what I called it. For this layer. Row index. Okay, that seems fine. Did I call it that though? Yes, yes. Good. So, right. And then we're just gonna be like, if the activation puts you in... Right. It's just that easy. It's just that easy. So you're like, yes, it already knows. No, don't color it yellow. Draw a yellow circle around the circle. Activations. No, you don't need to look it up. It's just if it has activation. We've already indexed into the thing. You don't want to index too much. Okay, so are we good? Let's check that. Oh my god! It's that easy. It's just that easy. I'm a coding genius. By which I mean GPT-4o. Okay, so yeah, I think we can actually do. Oh yeah, like what if I? Okay, so is this gonna survive if I like edit stuff? So if I say like 0 to 5, oh my words. Oh my god. Now, is this actually changing the activation? Like, because this one changes. So, yes, it changes the activation. Okay. That's amazing. That is like the easiest thing that I've ever implemented in my entire life. High five. Okay, so what we're gonna do now is we're gonna figure out a set of points that should be hard to separate. No. Well, meaning put them all in one. Actually, we can just do these. We'll just do these. We'll just do these guys. Okay. So we have the all yellows. No. We have the all reds and the all blues. And should I make this circle radius bigger? Nah. Like super small circles are awesome. Yeah, that's true. So okay, right, here we go. So what you want to do, right, so what we want to do is we want to put the yellow circles. We want to be able to separate them from everything else. Yeah. We want to be able to separate them from everything else. Using as few neurons as possible. I mean that, and I mean like that's actually pretty easy. So yeah, I mean that's actually pretty easy, I think. But I shall demonstrate. I shall demonstrate the, because basically what you do is you just you take the all reds, you make him the parameter vector, you put the hyperplane separating him from everything else. For the other one, yeah, I mean you're literally just naming the elements of the accept set as your parameter vectors. And you can always do that. That's like a universal. It just gives you like ostensibly exponentially large, like wide first layer. Yeah. Okay, so I'm not actually gonna do that because I think that'd take a while. Well, okay, let's just do it. Okay, so we want to make this guy's parameter vector equal all reds. I don't actually know how to do that, but it's like this is layer 0. This is the first unit, and yeah, I'm gonna have to fix this UI. But so we want to flip the parameter vectors. I think the second parameter we want to flip it. Good. And then I want to go back. So okay, so I'm gonna do 0, 0, 3, 0, 0, 3. Want to flip that. Boom. And then I gotta do the bias. Boink. I can actually, I mean that's fine. I can use that. Okay, then we have to do the same thing but for the next neuron. So it's like 0, 1. I think 0. Do we want that? Yeah, I think that's fine. Okay, so and then what is that? 3? Yeah. Okay, and then 0, 1, 3. 0, 1, 3. Okay, and then the bias. So 0, 1, 4. Oh. 0, 1, 5. 0, 1, 5. Okay, that guy. And why did that not work? No, I think it worked. It's no. Oh, well. Right. I mean, it's like you only need 2 neurons is the problem. So like if we only had 2 neurons, you would have, the yellows would be in blue, and, well, I mean, in particular, every other point would be one of these guys. But yeah, but these two all have the same first 2 bits. They're red, blue. So you just have to separate red, blue from the other 2. There you go. So that's complete proof of whatever. Okay, so we need to go back and generate like a hard point set. And for the selected rows, this shouldn't be hard. Shouldn't be too hard. And yeah, we want to generate like a point set of, so what you want is a point set where all the pairwise distances are relatively small, by which I mean relatively large. So if n equals 5, it's not entirely clear like how big a point set you can get. But we're gonna do like it's gonna be like also like, I mean, can you randomize this? Yeah, you can have like a randomization element because I mean, I guess like we'll like not randomize it first. So it's just gonna be like generate a set of binary strings of size n where the Hamming distance between any pair of strings is at least, yeah, I mean d. Do this by starting with, yeah, all zeros in the set, or like at every iteration filter the remaining strings that are all at least having distance d from every string in the current set. Randomly select one of these filtered strings if one exists and add it to the set. It's just that easy. Repeat until the set has k strings. Okay, so like, oh shit. Okay, what do we got going on here? Strings. Filtered strings, filter strings dot every let count okay, filtered strings. No, it's not. Don't I have a thing that gives you all binary strings? I thought I had a thing that gives you all binary strings. What the hell, man? Oh my god. I don't know what the heck it's doing at this point. Yeah, do that thing. Yeah, that whole thing. Yeah. Map number. I don't think you want a map number though. Then you want to do all binary strings. Then you want to be like, string 2 is greater than, right. So that'll work? So like, console, not log. Yep. So 5, okay, so it's like 5 and like 3. So, oh no. Oh no. Oh, yeah, I see what you're saying. Yeah, then we have to do like console and here. Okay. Yeah. Okay, let's do... Yeah, okay, let's do that. Going on. What, I mean, the hell? So that's distance 3, that's distance 4, and these are distance 1. Well, don't do that, just... Okay, so I gotta like manually, there's gotta be a better way of checking this. This is distance 3. This is distance 4, and then these two are distance 1, 2, 3. Okay, okay. And, okay, can you get... Okay, so that's 3 of them. And, okay, yeah, let's just do that. Let's just do 3 of them. Okay, so we just need to put those into selected rows. Find index. Sure. Okay, so we now should have 3 binary strings that are all distance 5. Which I mean distance 3. Which I mean at least distance 3. So we have like all blues. This one has 3 reds, so that's distance 3. This has 4 reds, so that's distance 4. And this one is like different here, and then on these 2, so that's distance 3. Okay. Okay. And it just so happens that this neural net separates these. Well, no. It does put them in the same... No, it doesn't separate them though, because it's... Yeah, like it's including a lot of other points. Uh-oh. Wait. Okay. Okay, yeah. So what you want is like, yeah, you want the output unit to look like this. because like you can separate these two. But but for this output unit, you want it to only contain the 3 yellows, right? Because like right now, if you select it, it contains a lot of points. Right. Right. Okay. So, yeah, I mean, this still has an easy solution where it's like you just individually separate every point. Yeah, I mean, yeah, right. Yeah, so we need like a bigger set. We need a bigger set. I'm not sure you can actually have a bigger set though. I mean, it has to be at least 6. So, I don't think you could run it with 6. I mean, at some point, like, it's just gonna... Okay, let me put in, like, a... Yeah. Okay. And... Because otherwise... It's gonna run forever. We'll give it, like, 10,000, you know? Okay, so let's see if we can find a set of size 4 for 3. Distance 3. I don't think you can. Wait, did I mess that up? So, like... Yeah... Okay, so it's saying it found one of 4. This is 3, 4, 3. This one is 3. And this one is 3. Okay, so it did do it. It's not... Oh, because I'm... Yeah, it's because I'm stupid. Alright, we got 4 strings. Let's go to 5. I mean, it might be easy, I don't know. Okay, now I'm not seeing 5 strings. So... What is happening? Zero, 4, 10, 25, 30. But it's saying it's... It's only putting 4 in the thing. I don't understand what's happening. It's only selecting 4, but like this is not. Why is it aborting? I don't understand why it's. Oh, because of the break. I see. Okay. Yeah, it's like, don't break, just, remove the last element from strings. Okay. Alright. Okay, so like now it's hitting max iterations is 0. Good. Okay, so if I go to like 4, I can easily find 4. But it's can't find 5. Okay, yeah, what, yeah, I mean, we should have done backtracking. Remove a random element from strings, not the first element. Yeah. I don't understand what that does. Alright, so we have 4, and then we're like, we want to have 5? Yeah, I just can't find one with 5, so we will kind of assume that it doesn't exist. Okay, I'll do one more. We'll search 100,000 restarts. Is this actually removing? I don't know what this 1 does. Whatever. Yeah. Okay, so that's not gonna find it. But if you only want 4, you can get 4. Alright, so anyway. Okay, so we're gonna see if we can figure out how to separate these 4 elements. Yikes. Yeah. Right, separate the 4 elements from everything else. Yeah, well, I mean, again, they all have kind of like the default solution, which is you just set them as a parameter vector. Yeah. Right. Okay, but what, okay, so but what if you only had 3 neurons? Right? Is this gonna break everything? Most likely. Yeah, that didn't work at all. Haha. The heck, man? Okay, yeah, so at some point I stopped respecting the thingy. And it seems like it would be here. Length n plus 1, yeah. What? Oh, I see. Yeah, but that should be... Whatever. Right. Right. Fuck. Yeah. Yeah, I'm just gonna take a break there.